This video talks about linear programming. In linear programming, you will minimize or maximize something. Take just a second, pause the video, and read through this problem to make sure you understand exactly what it's talking about. Now, when you do a problem like this, you want to focus on the question that it is asking. In this problem, it says, how many of each product should be made in order to maximize profit? So that question tells you a couple things about the problem. It will tell you what your variables are supposed to be. So this one says how many of each product. Well, we need to figure out what they're talking about. What are the products that they're talking about? And they're talking about bookcases and they're talking about desks. So the first thing that you want to do in any of these problems is to define your variables. And I'm going to define X as the number of bookcases and Y as the number of desks. So now we know what we're talking about. Now we need to read through and see if we can find some equations. Let's see, this one says each bookcase requires 5 hours of woodworking and 4 hours of finishing. Each desk requires 10 hours of woodworking and 3 hours of finishing. Now sometimes people get a little confused about their equations. Each equation needs to have both variables in it. So if in that first sentence we talk about 5 hours of woodworking and 4 hours of finishing, sometimes people would want to say 5x plus 4y. Well, x represents bookcases, and if you say 5x, you're allowing the woodworking to represent the x variable. So we don't want to do that. We want to let the x represent the bookcases and the y represent the desk. So we do know that there are 5 hours of woodworking for bookcases for the x value, and there are 10 hours of woodworking for the desk. So that's our common link right there, and that would be part of our equation. So we've got 5 hours of woodworking for bookcases and 10 hours of woodworking for desk. And we only have 600 hours for woodworking. So we've got up to 600 hours. So it could be less than or equal to 600 hours there. Now we're going to do the same thing. Let's clear some of this stuff out here. We're going to do the same thing for our finishing. We've got 4 hours of finishing for a bookcase and 3 hours of finishing for a desk. So 4 hours of finishing for a bookcase and 3 hours of finishing for a desk. Now, I won't lie to you, this is going to be the hardest part, is going through your problem and trying to find the things that go together. So you want to make sure that you have the correct variables by looking at the last sentence, and then find something that's in common with them. We looked at desk and bookcases and found out that we had 2 other things that we're looking at, and we had totals for each of those. So I've got 240 hours of finishing here. Now, in most of these things, you're also going to have 2 constraints of x being greater than or equal to 0 and y being greater than or equal to 0. Because these are application problems, the smallest number of bookcases or desks that you can make would be 0, so you won't have any negative numbers on any of this. So those are what's called your constraints. We also want to find a profit equation. And this sentence will usually come right out and say something about the profit is or something like that. This one, let's change a different color so you can see, says the profit on each bookcase is $75 and on each desk is $140. That would be your profit equation. It's not going to have an inequality in it. It's going to have both variables in it. And it's just going to say something like the profit, the cost, something like that. So this equation we might want to write like this. P for profit is equal to 75x, because the bookcases were $75 each, and the desk were $140 each. So that would be our profit equation. When we start graphing, you do not graph the profit equation, you only graph your constraints. Now remember that in order to graph, you're going to want to get y by itself. So we're going to focus on this first one. And I'm going to move the 5x to the other side. I'm not even going to worry about the inequalities right now. I'm just going to look at what I've got here. So I'm going to divide both sides by 10. 5 divided by 10 is 1/2. So we have one equation that we can graph. Now let's go to a piece of graph paper and graph that equation. When I graph this one, I'm probably going to go by 20s since I have to graph the y-intercept first. Remember, this is what we're graphing. So I'm going to go 20, 40, 60. That's my y-intercept. My slope is -1/2, so I'm going to go down 1 and over 2 and draw another point. Down 1 and over 2 and draw another point. Down 1 and over 2 and draw another point. Now, I've got to figure out how to graph the inequality part of this equation. So when I look at my inequality, let's go back and look at it. The first inequality that we had was 5x plus 10y is less than or equal to 600. When I take a look at this inequality, my inequality has to be less than or equal to 600. So if I pick a point on either side of my line that I am graphing, and I think I'll pick 0, 0, and I plug it into my original equation, it is true because 0 is less than or equal to 600. That means that the point that I picked is true, and the shading for this line would be below this line. Now I have to worry about graphing my other equation. My other equation was 4x plus 3y is less than or equal to 240. So if I try to get y by itself on that one, I'm going to end up with y equals minus 4/3 x plus 80. You've got to get y by itself, so I'm going to go up to the 80. Since the first one went up to 60, I just need to go up one more because that's up to 80. My slope is -4/3, so I can go down 4 and over 3. And I have a nice line there. Mine's a little crooked. Maybe yours won't be as crooked as mine is. See if we can fix that a little. Okay, now I need to pick a point on either side of that line, and I'm going to use 0, 0 again. I'm going to plug it back into my original equation. 4 times 0 plus 3 times 0 is 0, and 0 is less than 240. So this one would also be below the line because that works. So my shading, because of the constraints of the x is greater than or equal to 0 and the y, is right inside this box. And what I've got to figure out now are all the vertices. I have one here, and this is the point 0, 60. We can see that one easily. I have one here, which is the point 0, 0. I have one here, which is the point, let's see, 20, 40, 60. So 60, 0. And I have one here, which is going to be a little harder to see. So you're going to need to go back to where you learned about systems of equations and substitution and elimination and figure out where those two lines cross each other. So we had two original lines. We had 5x plus 10y is less than or equal to 600. And I'm just going to use equals because I don't really care about the inequalities. The inequalities are represented by my shading that I did on my graph. And right now we're just trying to figure out what x and y would be if those two lines crossed each other. So I prefer elimination when I do these. You might prefer substitution, But I look at this equation and I say, okay, I want to eliminate either my x or my y. So I might multiply this row by 4 and this row by -5 to make the x's go away. So the top row would be 20x plus 40y equals 2400. If I multiply the bottom row by -5, I get minus 20x minus 15y equals -1200. And when I do my elimination, 40 minus 15 is 25. 2400 minus 1200 is 1200. So the y value ends up being 48. So we have a y value of 48. We can take that 48 and plug it back up into one of these equations to figure out what the x value is. And when I put 48 back in there and I substitute it in, I get 4x plus 3 times 48 equals 240. I'm going to solve for my x now. And when I do that, I get x equals 24. So that line actually crosses at 2448. So that's what this one is. If you're really careful in your graphing, you might not necessarily ever have to do substitution or elimination. But if you have something that falls in the middle, you may have to do that. Now we have 4 vertices. This is where our profit equation comes in. You take those vertices and you plug them into your profit equation. So let's go back and find our profit equation. Our profit equation was P equals 75x plus 140y. So when I do the 0, 60, I'm simply plugging 0 and 60 in. And we want to use our calculators and figure out what that is. I'm going to put the 0, 0 in there, and that one's going to be easy. That one's going to come out to 0. This one is 60, 0. And the last one was our 2448. Those are the vertices for this one. So let's just do a little math and see what these come out to. Now, once we put the numbers in our calculator, we take a look at it. If you remember from the very beginning of the problem, we are trying to maximize our profit. So we're looking for the biggest number. Out of all of our totals that we see here, 8520 is the biggest. So that's how we would maximize the profit. So our final answer would be that we need to make 24, I believe bookcases was the X value, and 48 desks for this one.